We are excited because we have tons of questions that we are going to ask our very special guests. We have none other than NASA's Chief Scientist, Dr. James Green, with us. Dr. James Green was named the Chief Scientist at NASA in 2018, and he has had an awesome career with NASA. If you've read anything about him, and I think one of my favorite things about you is you were a safety diver at the Neutral Buoyancy Lab. I think that's pretty neat. So I'm sure he'll tell us a little more about that. But in addition to that, you have had your hand in several missions. The Messenger spacecraft that went to Mercury, New Horizons that went by Pluto, Juno that went to Jupiter, Grail to the Moon, and even the Curiosity rover, which is always a fan favorite around here at the Challenger Learning Center. So before we get started with our question and answer session, I'm going to turn it over to Dr. Green. So Dr. Green.
Well, thank you so very much, Jennifer, for inviting me to come and talk to the kids and let them know what's going on in NASA. Answer the burning questions that they may have about what we're doing now, what we want to do in the future, and where they might fit in. And we want them to be thinking about space. We want them to achieve greatness in school and come work for NASA. All right? How can you beat that?
All
Let me
right.
turn it over and let's get on with the questions.
All right. Thank you, Dr. Green. First up, we have Aiden Ledbetter.
I was wondering, if you were to make a sound in space, does it disappear or does it stay in one place forever? And if you were to put your ear up to it, would you still hear it?
Okay, that's a good question. How sound travels here on Earth is because of the air that we have. And in fact, sound even travels in water. So in this picture, in a tank where we have an astronaut and a diver, they're communicating actually through sound in the water. Sound travels because it has to have a medium to move back and forth and carry those sound waves. In space, we don't have the air. In space, we don't have the water. So when we clap, if an astronaut's got his gloves on and he's clapping, then she is listening, and all the other astronauts are there out in space with everybody. You cannot hear that. It's like they are on mute. So you need an atmosphere or some medium to transfer the sound waves. Now, you mentioned one thing of where does the sound go? Well, it doesn't travel from the hands, as I mentioned, an astronaut clapping his or her hands. But as the astronaut claps, they will feel that because they have air inside their suit and inside their gloves, and they will hear that they are making a noise. It just won't travel away from them.
Next up, we have Charlotte Bray.
My name is Charlotte Bray. I'm a third grader at Clark Elementary School. I'm in third grade, and I live in Dukin, Kentucky. Thank you so much for your time today. It was very nice to meet you. So my question is NASA able to track bird or butterfly migration from space? If so, which particular ones are visible?
Oh, that's a good question. We don't track butterflies because they're way too small. However, there is an experiment on Space Station that actually tracks a variety of animals, but it requires that the animals be tagged with a little transmitter. Now, some of the things that we've learned by doing that is that as we fly over certain areas and we see where these animals are, because we can sense them from space, sometimes we've even seen them move away in mass very, very, very quickly away from a particular area. And then within hours, there would be a little tremor like an earthquake. We've also seen them move away when there's huge waves hitting the shores that are a tsunami. And we're recognizing that the animals can sense danger. They sense the danger that is very hard for us to be able to figure out. And so by watching these animals move and getting out of the way, that may be an important way that we send alerts when there are problems like earthquakes or tsunamis, you know, these big waves that crash on the shore. So the migration of animals are very important to study, and we just started that process. But butterflies are too small.
All right, thank you, Charlotte. Next up, we have Sophia Ranella.
I'm Sophia Ranella from I'm an 8th grade at Lone Oak Middle School. I was wondering what missions you have coming up with NASA.
Okay, so one of the missions that we have coming up very soon, we just launched. And that particular mission is called Perseverance. Here is a model of Curiosity, which is sitting on the surface working right now. But Perseverance looks just exactly like Curiosity, except we've taken some of the instruments out and replaced them with new instruments. Now, this is just a little model, and the size of this rover, this 1-ton rover, is about the size of your car, an SUV. And so it is really a highly capable rover. In fact, if I were to stand next to the rover, I would be about that tall. The top of the mast, which has a camera and a laser on it, is above my head. And yet I am over 6 feet tall. So this particular rover is going to land on Mars on February 18th of next year, okay? And what we want to do is we want to be broadcasting so that everybody sees what happens in mission control as we land the rover. Now, the job that the rover is going to do is that it's going to, has a drill, and it's going to drill rock. And that rock we call a core. So here is a sample core that we drilled here on Earth with the instrument that's on Perseverance right now. And so it looks like, you know, one of those large Crayola crayons, okay, or a piece of chalk. And so we're going to core these, and then we're going to put them in sleeves like this. This will be a metal sleeve, and then we're going to lay it on the ground, and then the rover is going to go to various places and core rock. Now, one of the reasons why we want to know about the rock is the rock history tells us how the planet has changed over time. Now, we use that same idea here on Earth. When geologists look at rock and they look for various things, even dinosaurs are trapped in the rock record if you know where to look. And so we learn all kinds of things. The pages of history of any planet is trapped in the rocks that it makes, okay? Now, what's really great about these rocks, because we're going to bring them back home with another mission that we're going to launch in 2026. That's the mission that's going to go get the rocks. And so in our laboratory, we're going to be looking at these rocks, and we're going to see what they're made of. And we're going to look at how the atoms in those rocks are combined in certain features that we call a matrix, and that makes them what we call a mineral. Now, on Earth, we know that there are about 5,000 minerals on the planet Earth, okay? A mineral like diamond and feldspar and olivine and all sorts of different types of minerals, jade, opal, beautiful gems are minerals also. But what's really great is out of the 5,000 minerals we have here on Earth, 300 of them are made with the remains of ancient life. That's how we know Earth had life in its past. So by bringing back the rock record on Mars, we're going to go back in time, see how Mars changed, and maybe, if we're lucky, we will find those minerals that will tell us that life may have lived on Mars in the past. So that's a mission we're gonna all be watching.
Awesome. I know we watched the launch, the liftoff just recently, and it's just amazing to watch those. So we definitely are looking forward to that landing in February. All right, thanks, Sophia. Next up, we have Regan McGoolian.
Hello, I am Regan, and I go to school at Clark Elementary. I'm in 5th grade, and I live in Paducah, Kentucky. And my question is, other than Mars, where should NASA explore next, and why?
Okay. So we've explored many places in the solar system, but one place in particular we're going to go back to is this place right here. It's the moon. It's the moon. Our plan is to launch more missions to the moon over the next several years and make more measurements of the moon, particularly bringing back rocks from the moon, because those lunar rocks tell us all kinds of things about how the moon was made and how the Earth and the moon came into being. Now, we're planning also to send humans to the moon. And in fact, we're moving towards a schedule where we'll have the first woman and maybe the next woman, or at least the next man, standing on the surface of the moon in 2024. Now, yes, and where they're going is not where we've been before. They're going to go to the south pole of the moon. Okay? So the south pole of the moon is a very special place. We're finding out that many impacts that create craters on the moon, those in the south pole never receive sunlight. Okay? They're not like they are at other places on the moon where the sun shines directly overhead. On the south pole of the moon, if you stood there, you would watch the sun skim the horizon to make a full day. As the moon moves around the Earth in 1 month, that's 1 day on the moon. And so because the sun is skimming the horizon, the craters that are created have never been interrogated. We've never been in them. And we want to go in there and find things. And what we think is there is frozen water. Now that's really exciting because we have some ideas on how that water got there. But until we actually get into a crater and find that water and taste that water and understand much more about other material that is also with the water, then and only then will we know how it got there. So it's going to be an exciting next 10 years. You'll be able to see the first woman, and the next individual could be another woman walking on the moon very soon.
We definitely are living in a very exciting time with space travel.
Yes.
Lots of amazing things going on right now.
Yes, we
All
are.
right. Next up, we have Sarah Davis.
I am curious how NASA determines which type of science experiments to do in space.
Okay. So NASA works on several big science topics, okay? Or disciplines, we call them. The first discipline actually is earth science. We have a whole cadre of NASA scientists that study the earth, okay? They actually build satellites that create images of the earth that the Weather Channel uses. You know, all NASA satellites are being employed in understanding and tracking our weather, our hurricanes, our tornadoes, and the life in the ocean. And as I mentioned, the migration of animals also. Some are on space station, but some fly around the Earth. Now, in addition to Earth science, we also study the sun. And that field is called heliophysics. Helio meaning sun, and physics meaning the physics of the sun. And one of the features we're finding out about the sun is it's very active at times and then not so active at other times. There's a cycle, and that's called a solar cycle. Another thing that we find out about the sun is it's losing matter. It constantly outgasses. It's like it's exhaling everywhere. And we call that space weather. So all our systems, our spacecraft, have to fly in the environment that the sun makes for us. And so by studying the sun, we then also can alert any of our astronauts if the sun puts out some really hazardous material, which it does from time to time. Now, in addition to earth science and heliophysics, we have planetary science. And planetary science, it goes to all the planets. In fact, as we flew by Pluto in 2015, we completed the initial survey of the solar system. Okay? And then finally, we have astrophysics. And astrophysics has big telescopes that look and see galaxies like Hubble and see all kinds of things that are going on, not only in our Milky Way, but in other galaxies, other Milky Ways. Now, in each of these disciplines, we have a series of scientists, not only in NASA, but throughout the world. And for us to decide what is the next best thing is we get these scientists together every 10 years. And we ask them, what are the top science questions NASA should be working on over a decade? And they all study and write a report, and sometimes it will take them 2 years before the report will come out. And we call that report a decadal, but in that report, in astrophysics, planetary science, heliophysics, and earth science, those are the top fundamental questions that the science community has agreed to that NASA should go after. And so we're constantly looking at what's the next question we want to answer. And from that, we build our missions, we go to places, and we take data and work hard in answering those questions.
All right, next up we have Corey McArthur.
Hi, my name is Corey. I'm from Benton, Kentucky, and I'm homeschooled. I was wondering, does a piano sound differently in space?
Good question. Now, if it's above the atmosphere and you play it, same thing. You'll get the vibration of the strings, but nothing will be able to propagate the noise. However, if you took that piano and put it on the surface of Mars and played it, you would get a sound. Now, that sound will be different than the sound we hear on this planet, because the Mars atmosphere is very thin. It's not like our atmosphere. And so when it shakes and moves those vibrations, it will do it based on the pressure and the change of pressure creating those waves in the environment that it's in. So we're really excited about what that might sound like. So what we've done on Perseverance is we've put a microphone up here in the mast, okay, right up here, a microphone, and right here on the side, and we're going to turn those microphones on. And we're going to listen to the sounds of Mars. Like playing a piano, things will make noise. Well, what will make noise? Well, the wind will move by and we'll hear it. Okay? There may be a little shaking on Mars. We know that Mars has Marsquakes. So rocks may come down a mountain and we will hear it. And then as the rover moves, we will hear the turning of the wheels. And that's very important because if the wheels start spinning because they're caught in a sand trap or a dust trap, which does happen, that happened to Spirit, and we couldn't get it out, but we'll be able to hear that the rover is trying hard to labor and get out of a particular environment. So the sounds of Mars we will hear for the very first time, starting when we land in February.
All right. Next up, we have Nathan Franklin.
Hi, my name is Nathan Franklin. I am a 7th grader at Paducah Middle School, and I live in Paducah, Kentucky. And my question was, how do you feel knowing that something that you have worked on, that you have created, is being sent off to observe a different planet or a different star or a different moon?
That's a really good question. I have been involved in a number of missions where we work really hard building instruments, you know, and testing them and making sure they work, and then putting them on the spacecraft, and then watching them being blasted off the surface of the Earth and sent into space. But what's really exciting is when we turn them on and the instrument starts talking back and taking the observations we want it to make. And that is tremendously exciting because it's with those measurements that the instruments make that tell us the physics or the environment or the weather or how the sun works or how planets work. All those questions we want to answer are answered by the instruments we send and how we look at the data and interpret it. So that's really important. Now, in planetary science, we also like to bring samples back, you know, and as we talked about, for Mars, many scientists worked on an instrument that did nothing but drill into the rock and create, you know, a core that we bring back. And so they will take that core into the laboratory, into their big laboratories and analyze them. And so not only do we build instruments and send them, but the results of those instruments come back to us as data, or we get samples back and analyze them. So we have many ways to answer the science questions we want to know about. But it's really exciting. It's out of this world, let me tell you.
All right. Next, we have Kate Kimball Wyatt.
Hi, I'm Kate Kimball. I live in Paducah, Kentucky, and I'm a 4th grader at Concord Elementary School. And my question is, you've been a part of so many cool projects and missions. A lot of people probably told you that your ideas weren't possible or that they wouldn't work. What helps you to keep believing in your ideas and trying new things?
That's a good question. Indeed, I have written science papers based on observations from instruments that tell me a certain thing is happening, and many scientists don't believe it, and it causes controversy. Controversy turns out to be one of the most important things that we as scientists do, because it turns our attention to something we need to know more about. So those things are extremely exciting, because then it allows us to build more instruments and make more observations that resolve the controversy. Sometimes our instruments tell us the new things and everyone believes the results, and sometimes they don't. But it's when they don't answer those questions and give us more questions to answer and cause more conversations from different scientists with different points of view that really make the field exciting, because we love to debate. We love to, project our own opinions. So if you've seen the Big Bang Theory, those scientists don't always agree on everything they discuss. And that's the way this field is. This field is all about scientific curiosity, a discussion of what you know and what you don't know, and therefore determining what you need to know, and then figuring out how to go after it. Those are the things that the scientists love to do.
All right, thank you, Kate Kimball. Great question. Next, we have Kate Johnson.
My name is Kate Johnson. I'm in homeschool, but I go to Clark Elementary. What does an asteroid look from the International Space Station?
Okay, so we orbit the sun, and it takes us 365 days to orbit the sun. And we are made up of, this planet and all the objects in our solar system are made up of smaller things that came together. Now, we have many small bodies, many small objects that haven't become planets yet. And there's a whole set of them out in the asteroid belt. And that's this area between Mars and Jupiter. Now, that's an area where a planet should be, but it's not. And it's because Jupiter is so massive, it keeps these pieces apart. Jupiter's gravity influences their motion and keeps them apart. Sometimes Jupiter gets mad at them and pushes them around, throws them inward or throws them outward. So many asteroids come out of the asteroid belt and come to the inner part of the solar system, and they cross our orbit, or they fly by the Earth. And we call them near-Earth objects. And we're constantly looking for them. Now, we find them with telescopes here on the Earth, looking for those small asteroids. And some of them are as big as a football stadium, and others are as big as a car or a bus. They come in all sizes. And so finding them is very important, because we know some of those that cross our orbit as they orbit the sun may hit us, okay? And so by finding them, we want to know where they're going and when they come back, and whether we'll be in the way or not in the way. And so those are called near-Earth objects. And we make observations from spacecraft, from telescopes on the ground, from telescopes in orbit. Now, it turns out we've never seen them from space station, except when they come in. Now, sometimes these objects will fly into our atmosphere. Now, if they are as big as a bus, they may actually have pieces of those making it to the Earth. But things that are the size of a car will burn up. They'll burn up completely in the atmosphere. But bigger sizes will make it to the ground. So from space station, they will, on occasion, but rare, actually see a streak of light coming in. Just like a spacecraft re-entering, these are asteroids, these are near-Earth objects that came from the asteroid belt that Jupiter threw at us, and they're coming into our atmosphere and burning up. Now, should we be afraid of them? Well, we're just realizing there are some big ones out there. And we're also realizing that what killed off the dinosaurs was one of these objects that was several miles in size, really big, okay? And hit the Earth, and it caused a climatic change, global climatic change for many years, which then broke up the food cycle, causing these larger animals to starve and die, and killed off the dinosaurs. So the dinosaurs didn't have a space program, but we do, okay? So we're looking for them, we're finding them, we're seeing where they're going, and we have ideas on how we're going to change their motion if they come to Earth to hurt us.
Our next question is from Renee Dawson.
What things have been discovered through the missions that have surprised you?
Oh, there isn't a mission that we don't have that huge surprises come out of it. One of the things that happens is whenever we build an instrument, we want to make a measurement and we launch it, and we are expecting it to tell us these things are happening, they typically don't. And almost everything we do in space is a surprise, okay? Now, does that mean we're stupid? No. Does that mean we don't understand why things are the way they are? Yes, sometimes. Some things we still are very puzzled by. But there are other things that really surprise us. And so let me mention one that was really important. And it starts with this planet right here. Okay? Does everyone know what that is? Okay. That's the planet Saturn. And it has rings. It's a beautiful planet. And those rings, we wanted to know how old they are. Now, many scientists thought, well, those rings are left over from when it was made 4.5 billion years ago. Okay? And so they'll always be there. Okay? And we believed that. We had no reason to think differently. But we took a spacecraft called Cassini, which orbited Saturn, okay? And we got into an orbit where we went just above the atmosphere and below the first ring. We call that the D ring, okay? And we made 22 orbits there before the spacecraft finally burned up in the atmosphere. Now, we needed to do that because we needed to get this information, and this was the last set of information. Here's the surprise. When we crossed the ring plane, which is only a couple stories in thickness, we found material raining down. It was little pieces of ice that were melting, and this was raining down. We call it ring rain. And we measured that ring rain. And we know these particles are made up of all kinds of exciting material that probably came from a comet. And by making the measurements we did, we now know how old the rings are. They are not 4.5 billion years old. They're actually only 100 million years old. They're actually very young. And measuring the ring rain and how Saturn is destroying those rings, we calculate that in 300 million years, Saturn will have eaten all its rings up. Okay? So they're really a feature that we as humans are so lucky to see in the lifetime of the solar system, which makes this a beautiful planet to appreciate and enjoy while it lasts.
All right, looks like we may have time for 1 or 2 extra questions.
Super.
So if you have an extra question, just raise your hand and we'll see who has one there. I saw Nathan Franklin, if you want to go ahead and ask yours.
So this is kind of coming off the Saturn question. So you said that the rings were relatively new, considering the age of the solar system. Does NASA think it would be possible for Earth to get rings, or in a different planet to get rings, such as Venus or Mars?
Yeah, that's a good question. Now, we think the rings are created by collisions that are occurring of objects that are caught in an orbit. Saturn has many moons, 50, 60 moons. I think the number is 63, or maybe it's even more. And so these moons may have been hit by a comet, leaving this debris, or they may have been comets that have been captured in orbit that finally break up as they get close to the planet. We're not quite sure of that, but we do believe that this is made up of a lot of cometary material. So there's a lot of ice, and the rings are really like grains of sand in terms of size, like little ice chips, all the way up to size maybe of a baseball, you know, but probably not much bigger than that. So they're just pieces everywhere. So therefore, the only way Earth would get a ring today is if it had more than one moon or many moons that were very close to the Earth. So we don't have that, nor does Venus have that. So we probably won't have ever in the rest of the evolution of the Earth an opportunity to have rings like Saturn has.
All right, thank you, Nathan. Regan, I know you had a second question. You want to go ahead and ask that?
I was wondering if you have been around Bob and Doug.
No, I know many astronauts. Some have even been my bosses. And I've enjoyed working with them over the years. But I have not met either Bob or Doug.
Now you do know our astronaut, Kentucky's astronaut, correct? Terry Wilcutt.
Oh yes, I do know Terry very well. Indeed. That's one of the reasons why I'm here.
Yes.
What were you interested in 3rd grade?
Okay. So when I was young, I really had a variety of interests. And one of my very favorite interests was mathematics. Okay. I was really good in math. Now, it turns out I didn't try hard. Okay. And not all math is created equal. Some math I was really good at, and some math I wasn't so good at. Okay. And that's important to know. I also was really good in history, and I was really good in science. And so what really changed my whole perspective on what I wanted to be when I got out of high school was the fact that I had a chance to work at an observatory where I had a telescope that I was able to use at night. And I built instruments on that telescope. And I made observations and I took images and I developed the film and I printed these beautiful images of the sun and Mercury and Mars and Saturn and Jupiter and nebula and stars. And some of those ended up in magazines like Sky and Telescope. And so when I finished high school, I knew I wanted to go into science. I knew I wanted to be able to be an astronomer. Now, how I got involved in space was the realization that I could be that astronomer and not use telescopes on the ground, but use telescopes in space. Okay? And so once I realized I could do that, that really opened up a whole new window for me. And the University of Iowa, where I went, did that for me. And so what you want to think about is, what are you good at? Okay? And then what you would like to do with what you're good at. And the reason why you want to get into something that you're good at is because you want to be able to do something that you enjoy. You want to be able to think about exciting things and contribute and be creative and all those things that you are capable of doing, such that you excel in your life. And then the day of work goes by faster than your day at school, which sometimes may drag on. But if you get involved in something you're interested in, it really makes all the difference in the world. So think about what you're good at and then apply yourself. See if you really like those subjects. Now, let me mention one thing that relates to that. I talk to scientists all the time. In fact, I have a podcast. It's called Gravity Assist. Now, Gravity Assist is where a planet, okay, a planet affects the motion of a spacecraft. You go around the planet and it changes your direction and accelerates you towards a completely different direction by taking a little angular momentum away from the planet you fly by. That's how we ping pong through the solar system. But gravity assists happen to our scientists. How I got involved in the telescope in high school was from a science teacher who got me excited, who gave me a gravity assist, who changed my direction and accelerated me forward. And when I went to college, I knew exactly what I wanted to do. And there, I met other scientists. And one of the great scientists that helped me was James Van Allen. He was one of my mentors when I went to the University of Iowa. He's a very famous scientist. And he gave me a gravity assist to get involved in space, taking my interest from telescopes on the ground to observations made by spacecraft. So along the way, you're going to meet people. You're going to have places or activities or things that you get excited about. Could be a book. It could be events like landing on the moon. When we land on the moon, I want you to watch it. I saw all our landings on the moon. I was in high school when they happened. I know what they can do. They're powerful. You're going to watch one of the most exciting events in NASA's history when we land and walk on the moon again. Okay? And if you can see yourself in doing that and you can get excited about it, whether you're actually the astronaut that makes it to the moon or to Mars, or helps the astronaut make it to the moon or Mars, because you're involved in engineering or building things or working in science areas, and you're excited about it, then you will have a wonderful life, because you will be able to contribute to mankind and our future. And our future is here on Earth and also in space.
If you were talking about the asteroid impacting the Earth, do scientists have any idea where on the Earth the impact may have happened that caused the extinction of the dinosaurs?
Yes, we do know where it happened. And it happened in the Yucatan Peninsula.
Oh, close.
Very close. And right on the ancient shoreline of that peninsula in the water. It hit half water and half peninsula. Okay. And the size of it was about 6 to 7 kilometers in size. Okay. Which is about 4 miles or so in size. So a really big object. So when we look for near-Earth objects, we're looking for these really big ones. We're looking for the planet killers. And there are several there, and we've been watching them, and we're going to be okay for hundreds of years. You know, we don't have to worry about it, but we need to be vigilant. We need to watch them, and we need to continue to see them, because sometimes their orbit changes, and that's very important. We're at an asteroid right now, which is 500 meters, okay, in size. Here's what it looks like. It's called Bennu. Okay, this is a little model of it. Okay, and not all asteroids are long, you know, like hot dogs. You know, some are, some aren't. This one is nice and roundish, where it spins, where the equator, where material rolls down from the top and makes the equator have a little belt. This asteroid is going to come close to the Earth, really close to the Earth, passing between the moon and the Earth in 2133. Okay? And we're going to watch it, because perturbations by the Earth on that asteroid may change its trajectory to put it on a bad trajectory. Okay? Right now, we can't tell what will happen, but by watching these objects and how they move in space, we'll be able to determine what we need to do. Now, we have a really exciting mission coming up next year. We're going to launch a mission called DART. And DART is a spacecraft that's going to go and hit an asteroid and move it.
Oh.
Okay? And if it works, it will be one of those missions that gives us the ideas on how we will keep the planet safe from many of these kind of objects. So it is our first mission in planetary defense. And it's called DART.
That's interesting. I had not heard of that mission yet, DART, so I'll have to be looking that up. Awesome. All right. Any final questions before we sign off?
So I have a question for you.
Sure.
Okay. So I'm sure many of you know what this object is. Can you see it? It's Pluto. It's Pluto. So here's the heart. Okay. And it has two sides of the heart, just like a normal heart would. You know, it just has those two sides. One of those sides is a glacier of frozen nitrogen. Now, we breathe nitrogen, but it's so cold out in space that sometimes it will end up creating a solid and actually snow. So we know that the left side of the heart of Pluto is nitrogen snow. Okay? Now the nitrogen comes from the atmosphere. Pluto has an atmosphere. Now, this goes into the category of blowing our mind. Scientists were shocked to find Pluto with an atmosphere. Why? Pluto is smaller than our moon, and yet our moon does not have an atmosphere, but Pluto does. It snows on Pluto. Doesn't snow on the moon. The geology of the body, the planet, if you will, is spectacular. These glaciers move and destroy the surface, remolds the surface. It is a very active body. It's like it's still alive, like Earth. We have plate tectonics and we have weather. Many different things are happening on Pluto that's very similar. And so it's a very exciting object, and yet it is so far away. It's 40 times the distance away than Earth is from the sun. It's so far away. Okay? So my question is Pluto a planet or not?
Well, I will say around here at the Challenger Center, we say Pluto is a planet. We just have a special place in our heart. That's how we grew up. Pluto is a planet. So we say absolutely, yes, Pluto is a planet.
Right. Okay. So how could it not be if it has an atmosphere and it's geologically active and it's round and it's so exciting. Now for NASA, NASA doesn't make these names. NASA, the astronomy community decides what they're going to call things. So for Pluto, we don't care what you call it, a dwarf planet or anything, we are going to go back. This object is so important that we need to understand much more about it. So there might be missions in the future going back to Pluto that will have to show up in the planetary decadal, and they're working on that right now. But I'd be willing to bet there'll be, let's go back to Pluto.
Awesome. That's pretty exciting to know. So we can let others know about that, Melissa and Renee. When we've got kiddos here and we talk about Pluto, we can tell them what's possibly on the horizon for that. Awesome. All right. Well, if there's no other questions, Dr. Green, I just want to tell you a very heartfelt thank you. Thank you so much for taking your time and answering all these questions. It's very evident your passion lies with space, and as you can see, all of the kiddos that joined us are very passionate about it as well. And we just thank you so much for your time, and everyone, thank you for taking the time to submit your questions and pop on with us. Thank you so much.
Fabulous questions. I thoroughly enjoyed it. And let me tell you, this time went by so fast. You know, it's almost like a wink of the eye. And that's because we all enjoyed what we're doing. Follow your passion. Thanks so much.